All right, we'll take a look at these next two problems here. Now, these next two problems are some applications of linear equations. But this time we're going to be looking at applying two variables. We have two unknowns that are introduced in these next two examples, and we're going to do it using a system of equations. So we're going to do it by assigning two different variables and then creating an equation using those two variables. So with that said, let's read through what we're given and see how we're going to go about solving it. So in problem 6, it says Mia's ice cream shop makes a swirl that is a mixture of two types of ice cream. Vanilla ice cream costs Mia $4.25 per pound, and chocolate ice cream costs $5.40 per pound. This month, Mia made 133 pounds of the swirl for a total cost of $658.40. How many pounds of the chocolate ice cream and the vanilla ice cream did she use? So there's our unknown. So anytime we're reading through a word problem, that's our first step, is to figure out what our let statement is going to be. When I say our let statement, what are we going to let x equal and y equal? What are our two unknowns? Let's assign a variable to it. So I'm going to use x and y as my variables. You can use any variable you like, but I'm going to let x and y be my variable. I like x and y. Now, how many pounds of chocolate ice cream? That's one of my unknowns. So let's let x be the amount of chocolate ice cream. And again, that's in pounds. And then let's let y, right? I'll let y equal the amount of vanilla ice cream. So we got two types of ice cream that we're going to mix together to make this swirl, right? That's what we're looking to do, is make this swirl ice cream. And these are in pounds. So when I use two variables, all right, I've got to create two equations, right, using these two variables. I've got to create a system to solve it. So let's figure out how we're going to create our two equations. So one thing that we had in this problem is we had the total mix, right? It says Mia wants to make 133 pounds of this swirl. So we have two types of ice cream that are going to make this 133 pound swirl, which is chocolate and vanilla. So let's go ahead and write down our total mix equation. So our total amount. And with that, we have x pounds of the chocolate, y pounds of the vanilla. They total up to 133 pounds in this swirl. So there's one equation. So now we're getting somewhere. We've built an equation using these two variables. But right now, with that equation by itself, there's nothing we can do to go solve for x and y. So we got to create a second equation, create that system, and let's gather the other information that was given. So we were also given the prices in per pound for each ice cream and the total cost for the swirl that we make. So we can build a price equation. So let's build our price equation. I'll make a note here on the side. So we had $4.25 per pound for the vanilla, $5.40 per pound for the chocolate. So if we sell X pounds of chocolate, all right, we got a total of $5.40 times X, right, for our total from that. And then with vanilla, and vanilla is Y for us. Amount of pounds is Y pounds of vanilla ice cream. It sells for $4.25 per pound. So 4.25 times Y, right, would be our total from that. And altogether, it says the total cost of the swirl was $658.40. So there's our second equation, right? 5.40x plus 4.25y equals 658.4. Now I've got to go solve it. So to solve this, a couple things we can do. You can use substitution method and you can use elimination method. Two different methods. All right, well, let's introduce elimination method. So I want to show you elimination, and I'll show you a substitution. You can pick which way you like. But there's two algebraic methods that we went over in solving a system. Now, in the elimination method, our goal, the only way to solve is to get down to one variable, x or y, and then we solve for that variable. So elimination, we're going to do that by addition. We're going to try to add these equations together and eliminate x or y out of the system so we can solve for the other variable. So to do that, we got to create opposites with the coefficients of x or y. So we add, we get a sum of 0. All right, so let's look at these two equations that we're given. And with that said, we could focus in, for example, on the x terms, right? With the x terms, right now, if we were to add them together, we get a total of 6.40x, right? 1 plus 5.4. So that wouldn't help me. I need to make them opposites. So let's make these coefficients opposites. So right here beside this, I'm going to do my key step. I'm going to multiply equation 1. I'm going to need a negative 5.40. So I'm going to take negative 5.40 and times it through equation 1. So let's go ahead and do that together. So negative 5.40 times x. It's negative 5.40x. Negative 5.40 times y is negative 5.40y. And then we got negative 5.40 times the right side. So we'll go ahead and show that here. 133. All right, and we still got equation 2, right? And equation 2 is, again, 5.40x plus 4.25y equal to 658.40. All right, now let's go ahead and simplify. What is negative 5.40 times 133? So I'm going to simplify the right side over here. So I got negative 718.2. Right? So if you want, we'll go ahead and reduce that. Right? So that's negative 718.2. I'll circle that, negative 718.20 as we multiply those together. Negative 5.40 times 133. So now what I want to do is add these up. So let's take these two equations and add them up. So this is our elimination method. See, now if you look at our x terms, right, they're opposites. So we've got opposites now. So we multiply by that coefficient and made them opposites. So when we add these together, their sum is 0. They cancel out. And as we go to our y terms, let's go ahead and add those together. What's negative 5.40 plus 4.25? So go to your calculator and put that in. We get a negative 1.15y. And then let's add the constants together. Negative 718.20 plus 658.40. And I get a negative 59.8. So I add those together. So as you notice, what happens? What do we have in our resulting equation? So now we got an equation we can work with. So now we can go solve for y. So we've got that one variable. So to solve for y, all we got to do is divide out the coefficient on both sides. Divide by negative 1.15. And what do we get? Well, you can go again and plug that in your calculator. So y is equal to negative 59.8 divided by negative 1.15, which is equal to 52. Right? So y is equal to 52. Now remember, what does y represent? Y represents the amount of vanilla ice cream. So there's half our answer. So 52 pounds of vanilla. Now we still got to find x. So we got half our answer. So we got to find the amount of pounds of chocolate ice cream. Now to find x algebraically, this is what I call my back substitution step. We go back up and plug in to one of our original equations. So for example, we could go back to our original equation. So we had an equation 1 that read what? X plus y equal 133. So I'm going to write that down. We know x plus y equal 133. So we're going to take in and plug 52 in place of y now that we found y. So I'm using my first equation. Looks a little easier to work with. So that implies x plus 52 is equal to 133. All right, so out goes y, in comes what it equals. And now as I'm solving that, go ahead and subtract 52 on both sides. And I've got my other half. I found in my amount here of chocolate ice cream. So 133 minus 52, I ended up with 81 here. So that implies X equal 81. And again, that's what, 81 pounds of chocolate. So there's my other half. So to answer my question, let's go back up here at the top. We found our two unknowns. We had 81 pounds for the chocolate, and we had for the vanilla 52 pounds. So now we've got the amount of each used to make this swirl. Now I did that using what I call the elimination method. So again, there is a substitution method also. All right, so I'll show you that one too. All right, if you wanted to. All right, I'm going to show you right here beneath it, just to give you an alternative. We went over two methods. Doesn't matter which you choose. Now here's how the substitution method works. Substitution method says pick an equation and solve for a variable. Pick an equation, your system, and solve for one of the unknowns. Solve for a variable, solve for X or Y. So for example, all right, I could solve equation 1 for X. I'll write that here. All right, if we do that, all right, what would we get? If we were to solve equation 1 for X, X would equal 133 minus Y. Well, I like that because now we have an expression of Y that represents X. So we can substitute that into the other equation. So that's where you do your substitution step. So I'm going to make a note here. So I'm going to go plug that in to the other equation. So we're going to substitute that into equation 2. So as we do that, what will we get? So that would imply 5.40x. I just write 5.4. If you want to put 5.40 times x, that'll be 133 minus y. So again, I'm going to plug in what we just found, right? For x. X is equal to 133 minus y plus 4.25y equal to 658.40. So now you can see we've got an equation with one variable. So we're solving for y now. So again, that's the key step. That's your substitution step, right, in the substitution method, right? Then we can go distribute. As we do that, we get 5.40 times 133. And what's 5.40 times 133? We get 718.2. 5.40 minus y, that's minus 5.40y, plus 4.25y equals 658.40. And then we got some like terms, so we can add those together. So negative 5.4 plus 4.25, so that's negative 1.15y. Right? So 718.2 minus 1.15y, as we combine the like terms, equals 658.40. And then what do? You subtract your constant term over. So we would minus 718.2 on both sides. And then we have y by itself. So what is 658.40? Let's put it in our calculator. Minus 718.2. Double check our arithmetic. Negative 59.8. So now my equation reads negative 1.15y equal to negative 59.8. And that implies what? Y is equal to negative 59.8 divided by, right, negative 1.15, which is going to give you 52. So you can see how the elimination method works, right? So I picked an equation, I solved for a variable, and then I plugged that expression into the other equation. And then I'm down to one variable. I was down to y, and I solved for it, and I'm getting 52. Right? And then, of course, you back substitute. So we know y equal 52. Again, being a total 133, the other one's going to have to be 81. So you back substitute to get to the other half. So there's y. All right, so that's substitution. I did want to show you that, and we'll use that maybe in our next example. The next example sets itself up for the substitution method, but sometimes one method might be easier than the other depending on the equations that you built. So just showing you both. You pick a method you like, but again, you can see how to solve those. There's two methods we can choose. Let's go ahead and do the next example. Let's finish off these two problems. We got another word problem here involving two unknowns. So in problem 7, it says a scientist mixes water containing no salt with a solution that contains 30% salt. She wants to obtain 150 ounces of a mixture that is 20% salt. How many ounces of water and how many ounces of the 30% salt solution should she use? All right, so with this problem, we got another mixture problem. This is a percent mixture. So we see our question. There in the end says how many ounces of water. There's an unknown. So we're reading through our problem. We want to assign our variables to what we're looking for. So let's let X be the amount of water. All right, and the amount of water, of course, is in ounces. And this contains no salt, right? No salt in the water. And then Y, we'll let Y be the amount of 30% salt solution. So there are two unknowns, right? Now we're looking at a mixture. She wants to obtain 150 ounces of a mixture that is 20% salt. So we're mixing these together. So with that said, let's go ahead and get our two equations that we assigned two variables. I'm going to do my total mix equation. I'll do that first. So let's get our totals. So X and Y. So X ounces of the water, Y ounces of the 30% salt solution must total 150 ounces altogether. So there's my total equation. And then to build my second equation, I'm going to use my percentages. Let's do our percent mixture equation. All right, and we're dealing with salt, right? Salt mixture. So with that said, we're using water. Well, water, that has how much salt? 0%. So 0% X. And then we've got our 30% salt solution. So it's got 30% Y equal 20% in the mix. So 20% of 150. So I've got a 150 ounce mix total. So there's my percent mixture for my salt, right? So with that said, we're doing water and 30% salt. So again, water has 0, right? It's no salt in it, so 0%. So it's 0x. There is no X term right in that equation. So as you're simplifying that down, of course, 0 times X is just 0. So 30% Y equal 20%, right, of 150. And let's go ahead and convert that over to a decimal. So that's 0.3, right, 30%. So we're dealing with percentages. Go ahead and change them over to decimals. All right, now what is 20% of 150? That's not 180, so be careful. I'm writing this down wrong. All right, so let's go ahead and calculate 20% of 150 here together. And we know that 0.2, we put in our calculator, double check our work, we get 30, right? 0.2 times 150 is 30. So that implies 0.3y equals 30. Well, what do we have? We've got an equation with one variable. So we've already got our work done for us for substitution. So let's go ahead and solve for y. So right now, right, we can go ahead and solve for y, get half our answer. System working out nice. Using the linear equation here, we'll divide out our coefficient, right? So we've got, let's go ahead and simplify this. So y is equal to 30 divided by 0.3, which is 100. So we got 100 ounces of the 30% salt solution. All right, that's what y represented. So y equal 100. And now we got to find x, right? Let's go ahead and show that algebraically. Let's go get the other half. So to get the other half, I'm going to go back up and substitute. Do my back substitution step. So I'm going to go back up to the beginning. So we know we can take that original equation that we had of x plus y, right? That had a total 150. So that means I can take out y now and plug in 100. So we know, but the other's going to have to be 50, right, at this point. But let's show it. So I want to show our algebra behind that. So as we plug that in, so that implies x plus y. Put that here in black. So x plus 100. So out goes y, in comes my answer. And then as we solve that, right, we subtract 100 over and we get 50. So we've proven algebraically, right, using the substitution method, right, that x is equal to 50. And what does that represent? That's 50 ounces of water, right, that contain no salt. So there's our other half. So yeah, we found our two unknowns. That was pretty straightforward, right? We made it easy, and we did it using two variables. So again, solving a system of equations. So I hope that helps. So again, with these word problems, right, you want to make sure you're reading through it, gathering your information so you can create your equations, but make sure before you begin, you assign your variables to what you're looking for. So use what you call your let statement. Let x equal one of you know, y equal the other. So I hope this helps. We'll move on in a little bit to continue.